And this one may be called H-I-J-K-L-M. Okay? So you have different points on this block. Make a sketch of this diagram. Put on your pens and pencils. Look on the board. Everybody, stop what you're doing. Have to look on the board. You're going to write later. Put on all pencils. Look on the board. Let's say this is a block that belongs to what's your name? Akil Hines. So GGMC will give a name like H151/001. Okay? So you got a lottery. Lottery come out. You applied. Now in the necessary 3 months you're going to get blocks. So the lottery come out. And you got a block. Okay, Akil? And your block name is now H151/001. So you're excited, you got a block. You got a block. So what? Find your block. The minute you want the minister to come and show you where it is. Or you want the GGMC officers to come and show you where your block is. When housing give you out house lot, does that carry you and show you the house lot too? When you get a 5-acre land from the government to plant on the highway, they just carry you and show you where the 5-acre is. It's your responsibility to find the correct, don't just find it, but find what belongs to you. Because I'd be happy for you to find what belongs to me and spend all your money on my property. And I will tell you thank you very much. You understand what's going on? See why it's important to know how to correctly find what belongs to you? Because if you find something and say, oh, this is me block. You know, a lot of people might pay somebody to go and find a block for them. But what if this person show you a wrong block? How can you verify that indeed this is your block? You have no clue. You have no knowledge of reading a map. You have no understanding of using a GPS. Then you got to go by what people say. Then you're going to start taking out money from the bank and investing in money, taking it to a location that is not even yours. You understand what's going on? See how it's important to start on the right track. The right track is to correctly find what belongs to you in the bush. Hence, the only way for you to do that is to have a functional understanding of maps, of eastings and northings. And that is what we're looking at now. So, you are given this block and you want to start mining, okay? But SAR says the first thing you must do is to make sure that you find the correct plot of land that belongs to you. Find your own block. So this block has a point called I, J, K, L, and M. You understand? You therefore want to know how to read the coordinates of those points off of the map so that you could put them into a GPS so that you can then use the GPS to direct you to the direct locations of these points in the bush. That is what you want to do. And if you don't do it, then you'll have to pay somebody who knows how to do it And what is the cost people charge to go and find a block? Let me hear you.
100,000.
Where?
Yeah, 300,000.
500,000.
Depends.
Alright, let me talk Madio. If you got a block somewhere around Madio, how much money you'll have to pay? Tybee Creek, Conroe, around this area. We ain't talking far away, Coroni or Northwest or so. Let me say up to about Conroe or Corora. Let me say up to Corora.
300,000.
How much you will have to pay for a block within that range of distance?
300,000.
300,000? 500,000?
Depends.
We're talking about Guyana dollars?
Yeah, $1,000.
$1,000 bills, right?
Yeah.
500. Just to find your block. Right? This is not Nancy's story. This is reality. Okay? Right? Now you're not even a minor as yet. You want to become a minor. Your first operating expenditure is $300,000 to $500,000 just to find the block. Then you gotta move in the equipment and your ration and prospect the block and just to start it to find the block. Therefore, if you pay attention over the next couple of days, you will cut out the expense. You could do it for yourself. And if you continue with me for the next 2 weeks, you will get practice and you will do it before you leave here. We're going to go and find some points, some blocks. You will put on your long boots, put on your insect repeller, sharpen your cutlass, and you will go with the government GPS after you would have signed for it. And at that part, you have face on camera. So don't make no move. I brought 20 GPS, and I will put your name and your face on the camera to the GPS. So if you play that you're going to say it lasts, know that we got you on camera and we got you fully documented for the CID. So you're going to come back right. All the GPS now return
What
back.
about if you have your own GPS?
If you have your own GPS, it's perfect. You walk with it. So you learn how to use your own equipment. Okay? But the point I'm making is that this is important. What we're going to do here now is very important. So let's go. There are 2 points. If I'm to read the coordinates off of this map, there are 2 points I can read off quite easily. What are the 2 points? No, for the block, for this block. There are 2 of this 1, 2, Hij. This is supposed to be K at the top here. This one is L. This one should be M. And this one should be N. Right? You have 1, 2, 3, 4, 5, 6 points. Out of those 6 points, by looking at this block, are there any points you think you can easily pick up the coordinates of?
1100 meters east.
Somebody say 1100 meters east.
1500 meters north.
1600 meters north.
What point is that?
The east.
What point is located at that where you just called?
I.
Look at point I. Where is it located? What eastern line is it located on?
1100.
What eastern line is it located on?
1100.
I is
1100.
on 1100. And this same I here, this not the letter I, but the mark is on
1600 meters north.
Whenever you report the coordinates, you always look and see what eastern line the point is on, and write down the eastern line. Then look and see what northern line the same point is on, and write down the northern line. So what eastern line is this point on? So point I is on 1100 meters east, comma. What northing line is it on? 1600 meters north. And that's the coordinate that you will use to put in your GPS for point I. You got me? Take it down. So, what is the first number? The easting, isn't that so? Always put down the easting first, followed by what? The northing. Right now the coordinate of M. East.
1600 meters.
Northing is
1600 meters.
1600
Meters north.
meters north. Everybody have that? That's the coordinate of M. I want you to write down the coordinate of O, P, and Q. Write down the coordinate of O, P, and Q. That is how you read coordinates. You simply look and see what eastern line it's on, right? Followed by what? Northern lines. Always it's easting first, then northing after. Am I clear? Anytime you're reading coordinates, easting first, followed by northing. But let's come back to our block. The problem with the block is the government gives you this block, you get a lottery, you won, you're excited, you want to go and start doing something. You only know the coordinate of I, and you only know the coordinate of M. But then you have to find the coordinate of J, K, L, and N. Are they on any easting line and northing line? No. They're the between lines, isn't that so?
Yeah.
So we now want to look at what do you do when the points are not on a line, easting and a northing line. Okay? How do you know what to do? Let me give you another diagram and give you a fresh set of examples and test another 3 or 4 persons and see if we are on the same page. I can choose who will come out and do it. Alright? How does that sound? Sound fair? Yeah, that's fair. So I'm going to erase this diagram. I'm going to put another diagram on the board. And then we're going to come back to this block. I'm going to change the numbers. This is 5,000 meters east, 10,000 meters east. So take down this diagram from the book. And this is 25,000 meters north. This is 30,000 meters north. points, coordinates of these points. A, B, and C. Right on the clear side also, side, yeah. Right. Come on. Is he correct?
Yes.
Yeah, that's right. Give him a round of applause. When you're writing your meters is, keep it on the line, right?
Very good.
M, E, comma, right? Don't write the M and the N going up. On the line. Good, very good effort. Next person. B. Is he correct?
Yes.
So you have an understanding about coordinates already, right? We will take a break now, and when we come back, we will look at cases where you may have a block that looks like this. Okay? And these are the points you have to get the coordinates of. It's not on two lines, it's not on an eastern line and a northern line that you're seeing on the map, okay? So we will take our time and we'll go through such examples, okay? Let's have a look on the board. Okay, stop what you're doing. Let's look at the board now. So we understand how to read coordinates, and we understand it's the eastern followed by the northern. But then there are cases whereby they are points and they're not on the northern line. And we therefore have to understand another concept that is called map scales, or map scale interpretation. So head up for me in your books. Map scale interpretation. You ever take out a picture of yourself? A photographer take out a picture of you? And you get a picture. When you look at the picture, you say, wow, I look good. It looks like you. It is you. But you're not so small. Agree? But you're very small. You fit in a piece of paper like that. It's not so? That is called the image. Okay? So you have image, distance of you. It's not so? So when I pick up a picture of me, and if I were to take a ruler and I measure from the head to the toe, it might be about 6 cm. You understand what I'm saying? Okay? So my image distance might be 6 cm. Okay? My image distance. And that is because I have a picture of me. You understand? Very sharp. Alright? 6 cm. But then if I take a ruler and I measure my actual height, I will have a different measurement. Is that so? That's the object distance. Okay? And if I measure my height, I might find that I have 125 or 130 cm. Okay? So let's say it's 120 cm. And that's my height. As a matter of fact, I can actually go and measure it. I can stand next to the wall, come at you, measure how much rulers length you get. Let's just use the one. 1, 2, 3, 4. Good, stop there. Every ruler is 40 cm in this case. And then, let's say I'm here, 40, I have like another 15. So 40 by 4 is 160 and 15 is 175 cm. So I'm actually 175 cm. Okay? Everybody understand what I'm saying?
Yeah.
So my object distance is 175 distance here. But when I take out a picture, it's the image of me. It's only 6 cm. Okay? Then there is scale. The picture has been scaled downwards. Is that so? To fit onto the people. And then I can go and let the photographer do a big picture of me and put it on a billboard. Is that so?
Yeah.
It's the same picture of me, but it's just that rather than scaling downwards to make a small picture, they scale it upwards to make a bigger picture. Same image, small image, big image. But I am the object. You don't have small object and big object. The object is constant, isn't that so? I can't get small today and big tomorrow. I can remain the same height. Okay? But the picture, I could make it small and then I could make it big. Scale allows you to change the image of the object. So what am I trying to say? What is scale? What is scale? Scale is equal to image distance divided by object distance. Take this down. That is how you get scale. Image distance divided by your object distance. You know what this image distance is, not so? I mean, it was 6 cm. My object distance, when I measure it in cm, it's 175 cm. So, in this case, this is equal to, what is my image distance? 6 cm on the top, upon, what is my object distance?
175.
175 cm on the bottom. Okay? So that is scale. Image distance divided by object distance. Now, let us examine not me and my picture, right? Where the picture is my image and me and the object. But let us now examine the bush or the ground or the mining districts. Or Madhya. You know it's Madhya, right? And this is Madhya. Show you how the goal in Madhya.
There's not much.
This is the map
Of Madhya.
that covers Madhya.
The whole of Madhya.
The whole of Madhya. But Madhya is so small. You understand what I'm saying? So what is this going to be called? Object or image?
Image.
So the map of Madhya is the image, isn't that so? So rather than saying image distance, we can call it what distance? Map distance, isn't that so? Because we know this is not a picture, this is a map. But we understand that it's actually an image of Madhya, isn't that so? So this is the map distance. So this is what scale is equal to when you're doing map work. Scale is equal to, instead of saying image distance, the image is actually your map. So rather than saying image distance, you say map distance.
Divided by
Good. Divided by what?
object. Equal that.
Ah. Now, Madhya. Well, we call this map distance. And the distance on the ground in Madhya will be called the land distance or the ground distance. And we always use ground distance. So let us use ground distance. Ground distance. Okay? Everybody clear?
Yeah.
So when it comes to map work, scale is formed by dividing the map distance by say ground distance. Just now, I measured my height, and my height was 175 cm. Then I measured the height on the picture, that was 6 cm. And that is how come I know it's 6 cm upon 175 cm. This can be worked out to be in the fraction form. Cm and cm will cancel out. Isn't that so? I'm going back to school where we used to do fractions. Like we might have 8 divided by 12. Simplify. You used to get licks to this thing. What if the teacher says simplify, you start sweat? You gotta remember what you gotta do. One number could go into 8 and also go into 12. Could we use 3? Could 3 go into 8 without any remainder? No. Could 4 go into 8?
Yeah.
Alright. 4 into 8 is how much? 2. 4 into 12 is how much? 3. So a simplified form is 2 upon 3. Is that so?
Yeah.
Huh?
Yeah.
That's what you do. You divide the top and the bottom by a common number. Is that so?
Yeah.
A common factor. So rather than saying 8 upon 12, it is saying 2 upon 3 or 2/3. Right? Everybody remember that? Let me check back another thing. Let me look at another thing. They might say 6 upon 30. Simplify. What I'm going to 6 and going to 30 at the same time?
6.
Let's use 6. 6 into 6 is
Yeah.
1. 6 into 30 is 5. Agreed?
Yeah.
Remember those days? Let me go back again now. Teacher say, what I'm going to this number the top here and this number the bottom here.
5.
I want the simplest form. 10. 10 into 10. 10 into 40. That is the simplest form. Understand? End of that. You do this one. Let me hear you come. We're going to the one in top, we're going to the one in bottom. You do it.
I gave it 2 right
2.
away.
Walk. Right there, walk.
11:30.
So, 2 into 22 is?
11.
So 2 could go into 22 and you get 11. 2 into 60, give you 30. So it's 11 upon 30. These are simplification of fractions. Is that so?
Yeah.
Take a note of it. Bring you back, throw back Thursday, back in the days. I want us to now consider another piece of mathematics. And it's pretty easy. First time we gotta go back in the primary school, Form 1, period of our life, which is not too far away. Look, if I have 4.6, okay? I can simplify it so that I get 1 as the numerator. I can simplify it so that the number at the top, the numerator is the number at the top. This top number is called what? The numerator. And the number at the bottom is the denominator, right? I can simplify in such a way that at all times the number at the top is 1. How will I get the number at the top to be 1? I have to divide the number at the top by itself. Isn't that so? So if the number at the top is 2, divide 2 by itself. 2 divided by 2 will give you 1. So I'm picking my number. My number is always going to be the top number. Divide the top number by itself. Divide the bottom number by the number you pick, which is the top number. Is that so? So, in this case, I divide 2 by 2. And what I divide the bottom number by?
2.
2. So 2 into 2,
1.
6 divided by 2.
3.
So I have 1 at the top, and that's what I want. Okay? Make a note of this. I could have this one, 4 divided by 8. I want the top number to be 1 in the numerator. Therefore, what must I do? Divide 1 by what?
4 by 4.
4 by 4. And that will give me
1.
And why divide the bottom number by
4.
And that will give me
2.
And that's what I want. I want the top number to be 1.
1.
When we're looking at maths, and we're trying to find the scale this is what you must do. After you put the map distance, right? And you put the ground distance, right? Let's say, for example, the map distance is 100 by 100 meters multiplied by 100 is how much? 100 by 100 is how much? 10,000. So let us say I have 10 cm at the top as my map distance, and my ground distance is 10,000 cm. Let's just take these two numbers for example, okay? I'll show you how come I would get those numbers. But let's say whatever it is, map distance is 10 cm and ground distance is 10,000 cm. To get a scale, cm and cm must cancel out, is that so? Good. And then I must do what I said I must do here. So that the numerator must be 1. So what number must I divide by so that I could get 1 at the top? 10 divided by 10, is that so? So I will say this got to be divided by 10 to give me 1, okay? Upon this bottom number has to be divided by 10, and that will give me what? 1,000. So my scale is the number that is at the top, I put it first. 1, let me just put a little partition, right? 2 dots, and the number that is at the bottom, 1,000. And this is how I get my scale of my map. My scale is 1, the 2 dots means 2, 1,000. 1 to 1,000. If I look at my map here, which I will pass around, every group now has a map of the mapping area, including white hole, red hole, type creek, and it shows you all the minerals, the nice bright yellow. Well, in another couple of days, you're going to know how to read these maps, how to find those locations. So just calm yourself. Right? What we're looking at now is scale. So let us recap. Let's recap. We ain't doing nothing big and fancy. It's too simple to do. Let me recap. If I take out a picture of myself, the picture is the image, I am the object. To get the scale is the image upon the object. Agreed? When we come into map work, the image is called a map distance. Agreed?
Yeah.
And the object is called a ground distance. Agreed? Therefore, to get a scale, you have to put the map distance upon the ground distance. And when you get those numbers, one number on the other, apply what teacher used to teach you at primary school to simplify a fraction so that the numerator is always 1. What do? Divide the numerator by itself and divide the denominator or the bottom number by the numerator. Okay? And that's how we did. So in this case, 10 divided by 10 gives you 10,000 divided by the same 10 gives you, and the scale is 1 to 1,000. See how simple it is? That's how you determine the scale of a map. For instance, is 20 cm, and the ground distance is 5,000 cm. Okay? Let's just say so. Alright, take that down. And based on that, I want you to calculate the scale. What is scale? What divided by what?
20 divided by 1.
I didn't hear you.
Map distance divided by ground distance.
Correct. Scale is map distance divided by the ground distance. Which means we're talking about what's the map distance? 20 centimeters divided by what? I beg your pardon?
5,000.
5,000 cm. Cm at the top will cancel out with cm at the. This is not anything but a scratch on the board, right? What must I do at the top?
20 by 20.
Divide 20 by 20. What must I do at the bottom? Divide this number by
20.
Everybody see that?
Yeah.
Ah?
Yeah.
Good. When I divide 20 by 20, what will I get?
1.
When I divide this number at the bottom by 20, what will I get?
250.
250.
50.
Therefore, my scale is, let me write it here, 1 to 250. So this is our scale. 1 to 250. Alright? Once you understand scales, you won't have any problems in reading coordinates. This is the alphabet of reading coordinates. This. Understanding how to get a scale and understanding what the scale means. Okay? So let's work a few examples of scale. I'm just going to change this number here now. The map distance is now 15 cm, and the ground distance is now, let's not say 15, let's say 10 cm, and this is the ground distance. We'll find the scale using this example. And I'll ask some volunteer to come and mark it out on the board. Is she right, class?
Yeah.
Give her a clap. Our working is right, but our presentation needs a little improvement. For example, you don't need to put two equal signs here. You just need to put a division sign with one equal sign, okay?
Yeah.
So you're saying that 10 divided by 10 equals 1, 50,000 divided by 10 equals 5,000. So it's 1 upon 5,000. And the scale is 1 to 5,000.
Thank you.
Alright? Okay? And just to make it a little more complete, the 10 represents what? Map, distance, and the 50,000 represents what?
Ground.
Ground. So this is important in presentation, is that so? And what we find in here is scale. So I'll just put in these little pieces and make the complete cake with icing and those shiny little things that you put on it too. You don't want it just a piece of brown cake or a black cake just. But the white, cream, the green, and the purples and different colors, and the little jingles, and they look fancy. Right?
Yeah.
Good. Do you want us to work another example? You find the scale. The map distance is 4 cm. The ground distance is so much. Come calculate the scale for that. So scale is equal to map distance. What is map distance in this case?
4
4 cm upon, what's ground distance in this case?
5,000 cm.
Everybody follow me there?
Yeah.
Cm and cm cancel out, is that so?
Yeah.
What do you do now?
4 by 4.
4 divided by 4, so that you get 1, and divide the bottom by 4. How about you get?
50.
12.
50.
So the scale is
1.
1 to
12.
1250. 12 cm represents 60,000 cm. Do that one. Is it correct?
Yes.
Give me a round of applause. Everybody understand what we're doing?
Yeah.
I understand that not everybody will understand it at this point in time because it's something new. It's like you've seen a big fancy fireworks. They gotta take some time to sink in. So what you're gonna do, you're gonna go home, work with your friend. Can I send you home yet? Go watch your watch. Work with your friend and let it sink in. So we're gonna take our mind off of this scale. I know what we're gonna come up with now. Where did we get these numbers from? Where did I get 12 cm from as a map distance? Where did I get 60,000 cm from as a ground distance?
Imaginary distance.
No, it's not imaginary. We know how to make use of the numbers to calculate the scale. That's what we just did. But where did you get the numbers from? If we now going to look at that, okay? Let's look at the maps that we have in front of us. Let's look at this map. Do you see the eastern? Where's the top of the map? This is the top of the map, isn't that so? There's north, south, west, east. Isn't that so? What are the eastern lines? Lines coming down, isn't that so? Huh? The northern lines. The horizontal one, isn't that so? Come on, look at your maps. You're going to go and calculate the scale of this map. That's what we're going to do. Not no one, this one we're using now. We ain't ready for this yet. This is BMX. Still that tricycle. Alright? We will learn to ride first. Good. How do you get map distance? And how do you get ground distance from a map? You get all of that information from a map. By looking at a map, I can know what it is saying. What is the map distance and what is the ground distance. I put my map up there. Isn't that so? Where's my north? Top. You see the north arrow there? Good. My south is? My west is?
Left.
My east is?
Right.
Good. I'm seeing some lines coming down. Isn't that so?
Yes.
Those are what kind of lines?
East.
I see some lines going like this.
Northeast.
Alright. Which is the force eastern line coming down here? What is the value of that line? Good question. Look and tell me if you see any number for that line. The force eastern line.
SE. For 3 SE.
No.
Well, 4,000.
Now remember, I told you that the number could be at the top of the line and the bottom of the line. But in this case, there's nothing at the top, there's nothing at the but it's in the middle of the line. You see it in green?
24.
So that's the eastern. 245,000 east, so which means 245,000 meters east. Isn't that so? Everybody agree? So what's the force eastern line we got? 245,000 meters east. What is the next eastern line we have? 250,000, isn't that so?
Yeah.
Everybody see that? Huh?
Yes.
If you have see it, don't say yes. Everybody see it? If you have see it, say no. If you didn't see it, say no. Unless somebody show you it. What is the next eastern line?
260.
You have seen nothing right there, but you don't know it's going by 5,000, is that so?
Yeah.
So if this one was 245, then 250, some mistake the person make and they didn't have to put in the number, but you don't know it got to be 255, is that so?
Yeah.
Because the next one is what?
260.
Good. And then the next one got to be what?
265.
But then nothing there, is that so?
Yeah.
Then the next one got to be?
270.
And then nothing there, is that so? Then the next one got to be?
275.
But then nothing there.
No.
Then the next one is?
280.
But they have something there.
Yeah, and 285.
You see the 280?
Yeah.
And then the next one is?
285.
You understand what that?
Yeah.
So, that's how the Easterns roll. Let's go to the Northens now. The lowest Northern will be at the bottom.
555.
What's the smallest Northern?
555.
555,000 meters north. Is that so? You see that line?
Yeah.
Then the next one is what?
560.
Just don't tell me 560. Tell me the whole number.
560,000 north.
Meters north.
Meters north.
Good. So after that one is the next one is what?
565,000 meters north.
Everybody got that?
Yeah.
Next one.
570,000 meters north.
Everybody see that? Next one.
575,000 meters north.
Next one.
580,000 meters north.
Good. Next one.
585,000 meters north.
Next one.
590,000 meters north.
Next one.
595,000 meters north.
Anything right on the next one?
Yes.
What is written?
600,000.
Next one.
605,000 meters north.
Next one.
610,000 meters north.
They got any more?
No.
Alright. So you have looked at the map and you have successfully identified the easting lines on the map and the northing lines on the map. Well, my friend, the map can tell you both the ground distance and the map distance. Don't forget. My picture can't tell you my object distance. When I look at a picture of me, I could never know that I am so much tall. You understand what I'm saying? A picture could only tell you the picture distance. Is that so? But a map is different. A map tells you the picture distance and it also tells you the original distance. The object distance. Guess how it is though? You see these things what we call in so many thousand meters east and so many thousand meters north. What do you think there was distance there? On the paper or on the ground?
On the ground.
So guess what the map just told you there? Ground distances. So your eastings and your northings are ground distances. You got me? Don't forget that. The map just told you ground distances. But it doesn't say these are the ground distances. You just got to print out there. But you got to understand that eastings are actual physical distances on the ground. And northings are actual physical distances on the ground. So those are actual ground distances. So let us look at this. Let us look at any two eastern lines. For example, let's look between the first eastern line and the second eastern line. What is the first eastern line? 5,000 meters east. So let us sketch a line that comes down like this, and this is called 245,000 meters east. Isn't that so?
Yeah.
And then I sketch another line like this. That one is what? 250,000 meters east. What is the distance between this line and this line? The ground distance. Huh?
5,000 meters.
How much?
5,000.
Between 205,000 to 250,000 is 5,000. It's not so? So the distance is 5,000 meters. This is your what? Ground distance. How did you know it? By just looking at the eastern lines or looking at two northern lines. Everybody follow?
Yeah.
Make a sketch of that. So where's the ground distance? You're going to find the scale of which map? This map, is that so?
Yeah.
You see how I get ground distance?
Yeah.
Ground distance is what? 5,000 what? Meters. Alright? Any questions with that? Let's just find the ground distance off of a map. You could use two eastern lines or you could use two northern lines. Let's use two northern lines and see if we get the same thing. Let me choose the northern line at the top. What is the one? The northern line at the top of the map.
610,000.
And the one below that.
605,000.
So let me sketch it, right? So you sketch the one at the top. And what it is? 610,000 meters north. And the one below
605.
is 600 and what? 5,000
5,000.
meters north. What is the distance between 610 and 605? 5,000 meters. It's the same number, is that so?
Yeah.
So between two eastern lines or between two northern lines, the ground distance is the same, 5,000 meters. So the ground distance is the same 5,000. What we just found was what? But we now need to find from the same map, the map distance, is not so? How do you think you would find the map distance? I mean, you understand how we get the ground distance? By looking at two eastern lines, seeing what is the difference, and write it down. Or look at two northern lines, see what is the difference in meters, and write it down as the ground distance. But how do you think you're getting map distance? Go there for it. Anybody? How do you think you're getting map distance from your map? Let me give you a little clue. When I take out a picture of me, I am the object, and then the object distance, and the picture of me, and you get 175 cm. What will I do when I want to measure the image distance? What do I take? What do I measure? You measure the image, is not so? You measure the image, the distance on the image. So what do you think we have to do now?
Measure the distance on the map.
Measure the distance on the map. Between where and where?
The east and the north.
Between the two east ends or between the two.
North.
Everybody clear? And that is your map distance. So you have a ruler. You've seen the two eastern lines. Go and measure the distance with your ruler and tell me how much you get with your ruler. A ruler, when you look at this ruler, you have an edge, okay? And then a little in from the edge, you have a stroke with 0. Is that so? Then you have 1, 2, 3, 4, a half stroke, that's 5. Each stroke is an SM, is that so? 6, 7, 8, 9, and then you have 10, 1 cm, okay? Now if I have to measure with my ruler, where the stroke is at 0, I have to put that on one of the easting lines. Am I clear?
Yeah.
Not the edge of the ruler, but the stroke with a 0. And I want to measure to another eastern line that is here. This is 1 mm, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 2 cm. It's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 cm. So in a case like this that's on the board, if this line here is 245,000 meters east, and let's say this one here is 250,000 meters east, how much cm is between this line and this line? First, hold on, take it right. Every stroke is a 0.1 of a cm, because 10 mm or 10 strokes is 1 cm. Therefore, 1 stroke will be 0.1 cm. 2 strokes will be 0.2 cm. 5 strokes will be 0.5 cm. So let us go. From here to here is 1 cm. Then you have 2 cm, 2.1, 2.2, 2.3, 2.4. The line is closest to 2.4 cm. So that from here to here, when I measure to my ruler, I get 2.4 cm. And that could be called my map distance. Is that so? This is just a demonstration. You're now going to take your ruler and go and measure between two eastern lines and write down what you get as your map distance. Whatever you get, that will be your map distance. Measure it for yourself. Don't let nobody measure it for you. Measure it for yourself. Get up off your chair, bend over the map, and measure between two eastern lines or two northern lines. And write it down in your book. Where you get. Hold on, Uncle. Something's on your map there. Your book. Remove your book from there. Whenever you measure using a map, how much you get, class?
9.8.
9.8 cm is correct.
9.8 cm.
Okay? The distance between the two eastern or the two northern
All of them is
is the same thing. If you check all of them, you'll get the same thing.
9.8.
Everybody agree with me?
Yeah.
Can we use this?
Yeah.
Good. Here was the trick. Look at the working that I gave you before. Now you see where you get the numbers from? You see where the map distance and the ground distance come from? Right? That is where you get it from. I'm going to follow the same working that we did before to find the scale. But before we go there, there's one other thing you need to do. There's one other thing. Just pay attention. Put on your pencils and your pen and look at the board now. Now, if you notice, yeah, you ready for me? The map distance is in cm, but the ground distance is in two different units. One is in cm and one is in. When I give you the exercises before, the examples, all two was in cm. Check back, isn't that so?
Yeah.
It means that you have to have both of them in cm to do this work. You understand what I'm saying? So both has to be in cm. So therefore, you want to change the meters into cm. Or you could have changed all the cm into meters. What easier to do is to change meters into cm. What do you do? Let me ask you this question. US dollar is 1 US is how much Ghana dollar? 200. 12 US gonna be how much Ghana dollar? Huh?
12,400.
You see what I'm saying? What do you do?
Multiply.
Multiply. 1 meter, let me say 1 meter is a US. 1 M US is 100 cm, Guyana cm. Right? 1 meter is 100 cm. This is the conversion. 1 meter is equal to 100 cm. Therefore, 2 meters will be what? 100 multiplied by 2. Is that so? Huh? And that will be 200 cm. Therefore, 5,000 meter will be what? 100 cm multiplied by what? By what?
5,000.
By 5,000. Is that so? 100 multiplied by 5,000 will give you what?
50.
500,000. Yeah. Is that so? 100 by 5,000 will be 500,000. So if I wanted to change 5,000 meters into cm, right? I got to multiply the meters by 100. So I always multiply the meters by 100 to change it into cm. Let me write it down. Always put an asterisk. Always multiply meters by 100 to convert it into cm. Okay? So wherever the ground distance is in meter, just multiply it by 100 and that will give you the answer in cm. So this is 500,000 cm. So now the bottom number, ground distance then cm, and the top number then cm. That's what you want. The map distance and the ground distance must be in CM. Okay? Everybody understand what I said? Take it out. 9.8 cm. What's the ground distance?
500,000.
500,000 cm. So, let me just erase this. After erase, I can say right there. Alright, right. So for those who know what you have to do next, go and find the scale. So that the numerator is 1. I can get 1 to something. God calculate the scale of the map. God calculate the scale of the map. Of this map. Remember, it's this map we just draw the board, right? The ground distance and the map distance. So the map distance is 9.8 cm. The ground distance is 500,000 cm. I'd like a volunteer to come forward and calculate the scale of the map. Of your map that you have, this map here. Alright, which is ground distance is 500,000 cm, map distance is 9.8 cm. And that's the procedure you use to calculate the scale of any map. Every map you have will have its own scale. And this is how you calculate the scale. Is he correct? What did he do wrong, class?
9.8. Supposed to be 1.
You have to make the
This is
numerator
1.
Is that so, class?
Numerator is supposed to become 1.
Is that correct now?
Approximately, no. You leave out a 0. And behind the 2.
From here, calculate and select calculator.
Behind the 0.
Somebody let him a calculator, please.
No.
0, 2, 0.
Calculator.
Put a
Don't
0
tell him
behind
what to put. Let him put it himself. Let him put it himself. So let him use the calculator. I want to show all workings. Right now I see all workings. Workings can't beat you.
Oh, you're getting
First we got to divide by itself, class.
9.8 divided by 9.8.
Good, we're putting the work in there. Thank you very much.
Divided by 9.8.
9.8 divided by
Cut out the
9.8. Good. And then the bottom have to be divided by
9.8.
9.8. Good. Now, when divide the bottom number, 500,000 divided by 9.8. See where I'm getting a calculator.
0 is. I can take that.
So put first at the bottom there, not there. At the bottom first, put it there first.
Yeah, 0.
You sure there's a calculator showing you? 51,020.
Yes.
Yeah, that's correct.
20 is correct.
51,020.4, right?
Yeah.
Good. So 1 to 51,020. Round it off to the nearest whole number. So the 0.4 can drop and it'll be 1 to 51,020. Okay? So put the mark in 0 for make it 20.
If it's over the 5, you're going to put the 1.
Huh?
If it's over
If
5,
it was 5 or over 5, we'll make it 1.
21.
21. Okay? Alright, everybody understand what you did there? Please give the man his clap. So the scale is, 9.8 divided by 9.8 is 1. 500,000, this is 500,000, right? Divided by 9.8 is 51,020. Right? So that the scale is 1 to 51,020. Now, why did I ask you to find the scale? Normally, these maps are 1 to 50,000 maps. The scale, if we didn't go and do this, and a lot of people just buy maps from GGMC, and just walk it as 1 to 50,000 maps. But it isn't a 1 to 50,000 map. It is 1 to 51,020. So you have a difference of 1,020, whatever units you're measuring in. If it's cm on the map, so many cm on the ground. 1,020 cm. Error. That this map that you're working will have if you did not use this scale, but rather use 1 to 50,000. And these are ways in which, for a big block, it is not significant. Okay? But for a small claim, it is very significant. If there's a dispute between two claims, and there's a lot of minerals being made in a small area, let's say the size of this room, right? And somebody want to overlap their claim on this claim so that they could get in the action. Then a scale, using a map like this, and assuming that the scale is 1 to 50,000, right away you will be off. For every cm that you measure on the map, you will be off by 1,020 centimeters on the ground. And 1,020 centimeters divided by 100 is 10 meters, 10.2 meters on the ground, which is about 30 something feet, which is considerable when you talk about a claim and an overlap. Talking about 30 something feet. Sometimes there's where the string there. And you had that error due to the fact that the person who went and these things happen, These things can happen. And as we go along the course, I'm going to show you how there are many opportunities that exist for lands because of these kinds of scenarios. You might find a little strip of a little piece of land existing, just a little 10-meter strip existing. You understand me? Because when the person located or so on, they made the error in the old measurement because the map was not precisely 1 to 50,000, but it was actually 1 to 51,020. Just say, for example, and so you're off by 10.2 meters, or you're off by 30 something feet. And therefore, voila, there's a piece of land that is about 30 something feet in width. Might be another 100 feet or so in length, that is waiting for somebody to go and spot it, and the rest will be history. So don't ever start reading a map or using a map without first checking the scale yourself. How do these errors come about? These errors come about because the map maker, the cartographer, the person behind the computer that makes the map tend to round off the numbers. So in actual fact, when they're making the map, in the software it will show you 1 to 51,020. But because I don't know if it is their assumption or if it is for a matter of convenience, they will round it off to 150,000. And when they do that, or when that is done, what happens is that the map user inherently will have errors in all their computations. Every time you go to locate something, you will be off by 10.2 meters for every cm of distance on the map. Okay? Because you assume it's 1 to 50,000. So don't ever assume, don't ever trust, I shouldn't say trust, always verify the scale of a map. That's the best way of putting it. And this scale says, look what the scale says. At the top, under the scale bar where it says 1 to 50,000. You see that?
Yeah.
Because the man who made the map, he just decided to round it off so that it will be, rounded numbers. 1 to 50,000, 1 to 100,000, 1 to 25,000. These kinds of numbers. Nobody don't want to make a map and it's showing 1 to 51,346, for example. It looks awkward, but in actual fact, it's accurate. Awkward looking means nothing. Alright, good. So that's one thing to note when you go in and do map board. Everybody understand how you calculate scale? There's another map now. Let's look at the map of Madia. Now, there are two sets of units on this map. This one has the meters east, or the eastings and the northings. And it also has another system, which is the latitudes and the longitude. Okay? The latitude and the longitude. Now, map reading is careful work. It's not difficult work, but it's careful work. Okay? Let us look at this map here. You guys pull that one close to you. I have my copy. Okay. So, we have our map here. Isn't that so? On this map, you see the eastends. What's the first eastend do you see?
255,000.
Everybody see that?
Yeah.
Huh?
Yeah.
It doesn't have a line come down, but what does it have?
A
A tick. Remember I told you some maps could have the line come down, some will have a tick. Well, this is the one with the tick.
Yeah.
Okay? So you have a little tick there. And look at the bottom. You see the tick there as well. 255,000 meters.
Yeah.
Please. Everybody see that?
Yeah.
So let us sketch that. So what do I have? I have a tick at the top here. 255,000 meters east. And I have a tick at the bottom here. 255,000 meters east. Everybody clear?
Yeah.
Good. Next eastern line.
260,000 meters east.
Now, where you see 260,000 meters east, you see a number below?
59.
Minus 59 degrees,
10.
10 minutes, or 10 dashes, not so?
Yeah.
That is a different coordinate system. We're not going to look at that at the introductory level. We look at that at the intermediate level.
Next level.
Alright? But, do you see your tick?
Yeah.
Where?
Underneath the one.
Underneath the one. Excellent. Do you see a line drawn right down?
Yeah.
That line that is drawn right down, look right at the bottom. You see the tick also?
Yeah.
Where is the tick?
Between the 1 and the 0.
Between the 1 and the 0. That tick is for the 260,000. You understand what I'm saying?
Yeah.
However,
The line.
the line is not for the 260,000. The line is in degrees.
Okay, the 59.
Aye. Everybody follow me there?
Okay.
So that line there is not for the easting. It's for the degrees, minutes, reading. Everybody clear? Next one you get, the next easting.
265
1,000 meters east, is that so?
Yeah.
You see a tick, right?
Yeah.
And then at the bottom you see a tick, is that so?
Yeah.
Good. Right. So you see some ticks.
Yeah.
Well, if you see the ticks, you could choose any two ticks. And what's the distance between any two ticks?
5,000 meters.
5,000 meters. So what's the ground distance?
5,000 meters.
Everybody see that?
Yeah.
So the ground distance of this map is
5,000 meters.
ground distance is 5,000 meters. Everybody's clear? What's the map distance? Map distance is what? What you have to do? You have to go and measure to the ruler, is that so?
Yeah.
You go and measure to the ruler and then calculate the scale of this map. What are you going to do with the meters? Change it into cm, is that so? What are you going to do to make it cm? Times it by 100. And what it becomes? 500,000 cm, is that so? Can I get a volunteer to come up and work on the scale? Right? Yeah. Good. Is he correct there? What is the scale? 1 to 50,000?
Yes.
Correct. Here in this clap. Yeah, give man clap on. Alright, so the scale is 1 to 50,000. Now you see in this case, the scale is 1 to 50,000. Alright? And if you check at the bottom of the map in the middle, it has scale 1 to 50,000. Isn't that so? In this case, we verified, and when we verified, it was flush 1 to 50,000. What you will find therefore, this is the map that the land management division will make when they're selling you to the customers, so it will be accurate maps. This other map is a map that I asked somebody to make for me. So they didn't pay attention, as much attention, they do the one thing. You understand what we're on? So they put 1 to 50,000 when it was not. Okay? It was actually 1 to 51,020. So, you know, what am I trying to say to you? I'm trying to say to you that whenever you're going to go and use a map, go and verify its scale. Am I clear?
Yes.
Very simple to do. Check the ground distance by checking 2 eastern lines or 2 northern lines. And measure with your ruler the distance, and you work from there. Make sure that everything is in cm, okay? And you're good. We're now going to move on to the scenario of reading coordinates. And I'm going to refresh our memories by giving you an exercise to read some coordinates to me. So please take this diagram. And I'm going to use an example from this map. I'm going to say here is 260,000 meters east, 260,000 meters east, and here is 265,000 meters east. Here's 265,000 meters east. And I'm going to use 2 northern lines. And I'm going to use 600,000 meters north. This one is 600,000 meters north. And I use another one at the bottom here. And this one will be 595,000 meters north. Okay? Right? So here we are now. I have some block. As a matter of fact, let us look at this map. I want you to look at your map between these coordinates, between these 2 grid lines. Look between 260,000 and 265,000, and between 600,000 and 595. Okay? And you will see they got a block called M71/001. Everybody see that block?
595 or 600. Good mark. What is that one?
M71/001.
Yeah.
And full with gold. Everybody see that block?
Yeah.
And who own that block? M. Look at the legend. Look for M71. Who own that block?
Metal.
Metal. Who is Metal?
They don't know.
Some company that named Metal. METEL. Right? When was this block applied for?
Metal.
Ramon, no?
It was applied for in 1998,
The 25th
the
of
25th of August. Everybody see that information?
Yeah.
Good. Is it a prospecting permit medium scale or is it a mining permit? Huh? Now the name of the company is Metal. That is why you have the letter M. What did I say to you yesterday? Yesterday I said when it's a prospecting permit medium scale, it carries the letters of the name of the person or the name of the company. But when it's a mining permit, it will carry the letters MP. Okay? So right away, is this a prospecting permit or a mining permit?
Mining permit is MP.
MP. Does it have MP?
No.
So then it's not a mining permit.
No.
So if it's not a mining permit, it's a prospecting permit. Medium scale. And what are the rules of a prospecting permit medium scale? Look at the manual. The manual speaks to the land application process, how to apply for a block, prospecting permit medium scale, page 12 in your manual. How do you apply for that? Who can apply for a medium scale permit? Read what it says. An individual who is a citizen of Guyana and an adult, a partnership consisting of 2 or more citizens of Guyana, a company whose entire issued share capital is beneficially owned by citizens of Guyana or by a corporation which has been established by or under a written law in operation in Guyana, or partly by such citizens and partly by such a corporation. Once the company is registered on the Companies Act, therefore, that company can apply. It's not so. A cooperative society, a co-op society, if you register under the Co-op, the Friendly Societies Act, that co-op society can apply. A public corporation or any other corporate body established by or under any written law enforcing Guyana. So once you go and you register a company under the Companies Act, you can apply. Any organization established by the government, like the Guyana Mining School, could apply too. They'll have, you can apply. Or or under any written law enforcing Guyana and authorized to carry on mining operation. The Guyana Women Miners Organization, they have applied and they have gotten a block. Okay?
Yes.
To do mining for the members, to demonstrate. You understand? The Gold and Diamond Miners Association could apply. And any organization that have those formations and established according to these guidelines are eligible to apply. Apply no mean on get, but you are allowed to apply. Alright? Now, let us go to the page that deals with rental schedules. Prospecting permits medium scale. First year, 25 US cents per acre. Thereafter, an additional 10 cents per acre for each successive year. So that is what it costs to apply and maintain such property. Your homework is to read the land application processes. Okay? You are to read from page 6, from page 4 to page 34. From page 4 to page 34 in your manual. And come tomorrow for us to discuss it. These pages will cover the land application process for claims, the land application process for blocks, prospecting permit medium scale, the land application process for mining permits, the land application process for prospecting license, anything greater than 1,200 acres, the land application process for mining license, the land application process for quarry license. If you want us to do it into sand, you want to sell people sand, you have to apply for a license, quarry license, sand and stone. So page 4 to 34 in this manual will give you exactly what you have to do. These are the actual forms that you have to fill up, and they are filled up to show you how you must fill them up. Okay? Good. So if you don't read, you won't learn. Don't believe I will come and spoon feed you. Whoever read will learn. Full stop. Good. Now, let us attempt this question. We now have a case where we have our map and we have a block. Find the block. You just pay $2 million rent. You understand what that? Where you pay from, find it. Right? So how do you find this block? None of the points is on an easting and a northing line like before, isn't that so? So they're now off. Let us look at this point here. Everybody see that point? Everybody see that point on the block? Huh?
Yeah.
In the block M71?
Yeah.
And then you see this point here too? Huh?
Yeah.
And then you see this one at the top here too? Good. Let's say I want you to go and find the coordinates of those 3 points. Okay? This is what you'll have to do. This map, we know the scale is 1 to 50,000. Everybody understand how we got that? What it means that 1 cm on map is equal to what? 50,000 cm on the ground. Isn't that what we did?
Yeah.
Good. The 1 was at the top, isn't that so?
Yeah.
Remember it was like this first?
Yeah.
Huh? And the number at the top was actually what? Map, distance, and the number at the bottom was your ground distance. And then when you simplify it, it becomes 1 upon 50,000. Is that so?
Yeah.
So what it is saying is that 1 cm on map, or 1 cm map distance, is equal to 50,000 cm ground distance. Is that so?
Yeah.
Right? So let us call this point here E. And I'm just using an example. You will actually do the actual work on your map, right? We only have to go find east thing first, is not so? Right? Now, let us say, so this is 260,000 meters east. This is 265,000 meters east. Therefore, we know that point A will be on some imaginary line. Is that so?
Yeah.
Some eastern line. Now we're going to calculate what it is. And this eastern line going to run something like so. Is that so? But what is it? We don't know what it is. But what we do know is that we can measure the distance from this eastern line to point A with our ruler. Is that so? So we can take our ruler and measure the distance from this line to here. And let us go and do that, everybody. So take it, well, not everybody, don't do it yet. Because you're not draw down your eastern lines and so on, right? Let us say, let us say it's 4 cm.
Yeah, I actually get it.
Yeah, it's around 4 cm, right?
Around 4
Let us say it's about 4 cm. Let's say it's 4 cm, okay? Everybody look at the board. I mean, when you draw down your eastern lines, you're getting the real thing. Good, but we ain't doing it yet. We're doing the scenario first. So when I measure from this eastern line to that, I found it is what? 4 cm. You come back to this map scale thing here. 1 cm on the map is 50,000 on the ground. 2 cm on the map can be how much on the ground?
100,000.
3 cm on the map can be?
150.
4 cm on the map can be?
200,000.
See what going on? So a shortcut way of doing it is like this. Whatever you get there, 4 cm, just multiplied by the scale, 50,000. Is that so?
Yeah.
And what you get? 200,000 cm. Now, from here to here is 4 cm on the map, but it's 200,000 cm on the ground. But we can't, if I tell you, man, go and find this graph for me in Manual and measure 200,000 cm from a certain point. You're going to be stressed. Because to measure the distance in cm, it's hard, isn't that so? So rather than reporting it in cm, you want to report it in meters. So to change cm now to meters, you divide by 100. When you were changing meters to cm, you multiply by 100. But now when you want to change back cm to meters, you divide it by 100. 2 knots, 2 cats out 2 knots. And when you get 2,000 meters. So from here to here is 4 cm on the map, but on the ground is 2,000 meters. Everybody follow me there? So this is what we're going to write. From here to here, what we're going to write. MD means what? Map distance. MD equal 4 cm. Agreed? GD equals what? 2,000 meters. No cm. The ground distance is in meters. Isn't that so? So, if here is 260,000 meters east, it might be 261, 262, 263, 264, 265,000 meters east, 266, 277, and as we go into the east, it increases, isn't that so? So all you got to do to find the east tip of point A, you say east tip of point A is the 260,000 that you're starting from, is that so? And how much you got to add because you're increasing, you're going to the east. Once you go to the east, you have to add it, isn't that so? You now have to add 2,000 meters. And when you add it, you get 262,000 meters east. And this is the easting of point A. So I put A brackets 262,000 meters east, comma, and then we make a space for it. So I can take it down. make a sketch and write that down. We'll go it again, don't worry. It's just the first pass. What I just did was stimulate your memory, stimulate your mind, and let it see how close you are to the finishing line. Already. You understand? How close you are to reading coordinates of any points on the map. Just a few steps, and boom, you're there. You know to calculate scale. Boom. Alright, so what I'm trying to get at now is you will have a map like this, and let's say this is 260,000 meters east, right? And let's say this one is 265,000 meters east, okay? At the bottom it's 260,000 meters east, 265,000 meters east. Everybody clear there?
Yeah.
And we have two northern lines. This one is what? Let's say 595,000 meters north. And this one is 600,000 meters north. I'm just using a scenario, right? 595,000 meters north, 600,000 meters north. Okay. Let us recap. Tell me what's the coordinates of this point here. P. Everybody write in your books. Write the coordinates of P. And then write the coordinate of Q. I'll give you 3 minutes. Brackets, right? Good. Is he correct? Yeah. I give the man a clap. Good. Do I erase that? Huh?
Yeah.
Good. So I'm going to erase up. Now, there might be a case where there's a block that probably goes something like this. You understand? R51006. Some block, okay? And this is a point here. This is a point here. This is a point here. Okay? If I tell you that from here to here, is 8 cm, and from here to here is 8 cm. I want you to go calculate the scale of this map. I want to calculate the scale of this map. What is the map distance? What is the ground distance? What is the ground distance? Huh? The map distance is how much? 8 cm. What is the ground distance? Huh? Start there, you know. How you get 5,000? by checking between two eastern line or two northern line. Is that so? Let's always get ground distance. Check two eastern line or check two northern line. So write down your ground distance, write down your map distance, make everything cm. I'm going to calculate the scale quickly. And write down the map distance. That's right.
5,000 cm.
It's 5,000 cm, is that so? When you multiply by 100, what it becomes? 500,000. It's not 5,000, it's 5,000 meters, is that so? And when you multiply by 100, it becomes 500,000 cm. Everybody agree? Ground distance. Good. What's the map distance? That's the distance between the lines, is that so? 8 cm. What is the scale? Scale is map distance divided by ground distance. What is the map distance? 8 cm. What is the ground distance? 500,000 cm. Cm and cm cancel out. 8 divided by 8 gives you 500,000 divided by 8. 62,500. So the scale is 1 to 62,500. Everybody clear?
Yeah.
Make sure you have that. Take that down and let me know when you finish writing it down. What this scale is saying is that 1 cm on the map is equal to 62,500 cm on the ground. That's what it's saying. Therefore, 2 cm on the map will be 62,500 multiplied by 2 cm on the ground. Is that so? And that is what? 62,500 by 2 is how much? 65,000. Is that so? 125,000. Is that so? That's what 2 cm on the map means. Is that so? So let's say, for example, I want to get a coordinate of point A, right? And I know that when I measure my ruler from here to here, it is 2 cm. Is that so? Right? So I say 1 cm on the map is so much on the ground. Now I got to find for 2 cm. Is that so? Because from here to here is how much? 2 cm. 2 cm is so much cm on the ground. Is that so? But you don't want it in cm, you want it in meters. Say divided by 100. When you divide by 100, it is 1,250 meters on the ground. So 2 cm on the map is so much on the ground. This is a main part. What they say, people, is that when I go from here to here on the ground, I gotta walk 1,250 meters from this this eastern line, and then I'll catch point A. So if here is 260,000, and I gotta walk 1,250 meters more, and if I'm going so I have to add, then I have to add 260,000 plus 1,250, isn't that so? And that's the eastern. So to get it eastern of A, it will be 260,000 meters plus 1,250 50 meters. I'm gonna give you 261,250 meters. And because it's going east, you put east, and this is your easting. And we'll close with that for tonight. Homework, you'll find the easting of point B. From here to here is 6 cm. Do that one. And point C. From here to here is 4 cm. Just take the drawing. So in this case here, you're starting from 260,000, is that so? In this case here, you're starting from where? 265,000 and you go in, okay? So take on this sketch and you'll do B and C for me.